Alright, so we looked at overloading and we looked at a simple example where you have two functions with the same name, average and average. The difference is, in this case, the number of parameters. So you can have number of parameters, you can have types of the parameters be different, you can have the order of the parameters be different too. Those are all valid examples of overloading. And I do want to emphasize that in our previous example, I realize it's a little bit complicated. These two functions are overloaded. So you do actually have two separate functions. All right, so this is C++ allows this. So this is something we could not do in Java, but you can in C++. What is it that you cannot do is if you have both of these functions have exactly the same type, even if you change the names, that doesn't make a difference. This is not overloading. Okay, so if you have func int a int b and func int x int y, well, the signature, that is the name and the list of parameters, are not different. Even though you use different names for parameters, that's not important. It's the name of the function that's important and the types of the parameters and the order. Okay, so for example, all you have to do to make this unique, that is, make this overload func, is you can have call by reference, and now it's unique. It's a different problem of for the compiler to resolve which function to call. So here they are overloaded. There's a different problem associated with, well, compiler has to resolve which of these functions you mean to call. And so that's slightly different. Okay, so if you have int, that's a problem. But if you have double, this is overloaded. You have a double here, certainly this is overloaded. So if you have, this is, you could say that each of these functions have one int and a double, but they're in different order, and so this means that they are overloaded. So the C++ compiler will recognize these two functions as being separate. Okay. So this is all okay. Now in this case, let's see what the problem is. If you call it with two ints, this should be okay. Let's check this. Yeah, it's okay. So if you call two ints and you have one function with two ints and one function with the same name and a double and an int, the best match is this one. So you can check it out. This is the one that will get called. All right. So when you call an overloaded function, which one gets called? You look at the best match. That's how C++ decides. So let's say you call an average. You use the average function with two parameters. Then you're going to get two arguments. Then you're going to call the two parameter average. If you call average with three arguments, it calls the three parameter average. So that's pretty straightforward, same as Java. The compiler always resolves the invocation, that is, this is the invocation, based on the signature of the function call. And the signature is name and parameters. Okay, so matches the call with the appropriate function. Each of the overloaded functions is considered a separate function. And in our complicated example with the call by reference, this is not overloading, but this is overloading, but this poses other challenges. So even though this is overloading, the compiler does not have enough information to figure out which ones of these you mean here. And there is no way to resolve this. So yeah. Okay, so there are some overloading pitfalls. You only want to overload the same task functions that do the same task. So for example, a miles per gallon function should always perform the same task in all overloads. Otherwise, you'll get unpredictable results. And so you want to basically decide your function tasks wisely. So when you look at what C++ uses to resolve a function call, first thing it does is look for an exact signature. And if it doesn't find one, then it looks for the closest match or a compatible signature. So now you can have a lot of problems, or you could have problems with the closest match. So for example, there might be multiple things that could be the closest match if it's not an exact match. So first, certainly you look for an exact match, or C++ compiler looks for an exact match of the signature that is the same function name and exact match of parameters. Second, it looks for, if it doesn't find an exact match, it'll look for a compatible match. So it looks for anything that is assignment compatible. That is, even if you can, when C++ can do automatic type conversion, then it'll say, okay, this is a match. For example, convert the int argument to a double, then it'll take that. So first it'll take promotion. That is, let me just take a quick example. So let's say you have int x and double y. Okay, so we can't really tell by running this which one gets called because they're both called by value. But in this case, if you can see that this call with an int and an int is an exact match with this one. It's not an exact match with this, so you know that this is the one that will be called. And really, with this simple example, there's no way to distinguish the output. They do the same thing. If you have two doubles, well, first let me back up. So if you have one double, then you know for sure that this is the exact match. And once again, there's no way to check in this simple example, but you can cook up an example where you can print out something, and you can tell that if you use this and pass an int and a double, it'll call this. If you use two doubles, then there is a little bit of ambiguity, but you can check this out. But my guess is that C++ will say this is the closest match because one of them has an exact match, right? One of the parameter lists, and the other one has to guess. But this, I'm guessing this is the one that C++ will pick, and you can check it out. So it'll go with first with the promotion of an int to a double, and then only after that will it go with a double to int. So in this case, you're passing in into a double. Which one will it pick? Actually, it's not exactly clear in my previous example. These two rules will not tell you. In this case, if you call it with two doubles, this is the perfect match. Will it do this? Yes, I think it will. But the rule on the slide doesn't tell you which one it'll pick. So the problems come around when, let's say you have three functions, one with an int and a double, second with a double and int, and then third one with two ints. If you have two ints in the arguments, two int arguments, definitely this is the best match. So for this with two ints, this function is the best match. If you have one double and one int, here is a perfect match. So that'll work. Now, here's the problem. If you have two doubles, alright, so now which one will it call? Let's see if you can figure out. It can demote this double to an int, or it can demote this double to an int. So yeah, it's definitely not clear. Which one will it call? It's either one or two. And my guess is you'll get the same kind of error message we saw when it was not clear which of the two you mean to call. So remember, when we did call by reference. And we had two ints. This is not overloading. This is overloading, but now it's ambiguous, how you use it. Okay, so we had this. It's not clear which one you mean in either case to call. And so that's a similar situation here. You'll get a similar kind of error message. Which one do you mean to call? Basically, you want to just avoid such confusing overloading or such confusing calling, really, is what you want to avoid. The overloading actually is not confusing. It's actually the way you're calling it. It's confusing. So once again, these three, you can do this. Although there's no problem with doing stuff like this. Calling it like this is a problem. Okay, so automatic type conversion. You can, if you have numeric formal parameters, typically you can make it into double. So if you pass in an int, you can automatically type convert to double. So that's valid for assignment, and that's valid for passing parameters as well. So any subordinate data automatically promoted. So if you have ints, it'll promote to a double, floats are promoted to a double, cars are promoted to a double, and these are things we did not have to worry about in Java. We did not have our automatic type conversion. We always had an error message, basically. It's the difference. Java, it'll give us an error message if we try to do this. Try to assign, what are we trying to do? We're trying to, if you try to assign a double to an int, we get an error message. Okay. Oh, wait a second. So actually, I take that back. This is all allowed in Java. Well, back up. These two are allowed in Java. And I don't think you can do car to double in Java, because this is promotion. I misread this. This is promotion. The automatic type conversion that's not allowed in Java is double to int. So sorry about that. So double to int or double to float. The other way around, that kind of automatic type conversion is not allowed. These are allowed in Java. And of course, they're allowed in C++. Okay, so let's take a look at this function. Doesn't matter what it does, it just takes two doubles. And so if you pass an int and a double in Java, this will work. In C++, this will work. If you pass in a double and a double, no problem. It's exact match. So yeah, everything works. If you pass an int and a double, then this int is promoted to a double, no problem. Java will take this, C++ will take it. Okay, so that's all the same. If you try to do it the other way around, then you have problems. So the way you'd run into problems is, let's say if this was an int and this was an int, then this would work. So assuming these are two ints, this would work in C++ and Java. This would not work in Java if these were ints. This was int, this was int. Pass in doubles does not work in Java, but it works in C++ because C++ has automatic type conversion. You throw away the fractional part. And similar thing here, if the arguments were an int and a double and you had two ints as the parameters, then it would work in C++ but would not work in Java. Okay. All right. Another thing that your C++ that we do not have in Java is default values in arguments. We'll take a look at that next.